Absolute value equations. We're going to go over some practice problems on how to solve and how to evaluate. So here, the first thing we want to do is we want to simplify what's in absolute value. So we're going to take 2 and multiply it by -5, and that's going to give us -10. And then we're going to add the 1, and that's going to give us -9. We're going to keep our absolute value bars, and we get -9, and then take a look. What's outside of that is a 2. Well, the absolute value of -9 is 9, so this is 9 times 2, and 9 times 2 is 18. So to evaluate, make sure you work with what's inside absolute value bars using order of operations. Second one, we're going to concentrate on what's inside the absolute value bars. -2 minus 3 times 4. Order of operations, we're going to do what's in parentheses first. We have 4 times 3 is just 12. We have the negative in front of it and -2. All I did was wrote down what's there. So take a look. I brought the -2 down. 3 times 4 is 12. And I also brought my negative down. So let me rewrite that. -2 minus 12. That's -14. In absolute value bars, look up here what's outside absolute value. That's multiplication. And then out here is addition. The absolute value of -14 is 14. And we're going to multiply that by 4. Scroll up a little bit. 4 times 4 is 16. 4 times 1 is 4. That's 56. And then we're going to add our 1. So the final answer is 57. One more. This is an equation. So what we want to do is we want to isolate the absolute value and set up 2 equations. Yay, it's already isolated. So this is 1/3 x plus 5 is equal to 7, and then 1/3 x plus 5 is equal to -7. We're going to subtract 5 first. We get 1/3 x is equal to 2. We're going to multiply both sides by 3 to get rid of the denominator, and we get x is equal to 6. Over here, we're going to subtract both sides by 5, and we get 1/3 x is equal to -12. In order to get rid of my denominator, I'm going to multiply by 3 on both sides, and I am left with x is equal to -36. So those are my 2 solutions there. Let's practice one more. Take a look at this one. 5 minus x is equal to 6. Hit pause and try it on your own, and then come back and see if you got the steps correct. Alrighty, here we go. And taking a look here, I set it up as 2 equations. Once I set it up as 2 equations, I subtracted 5 on each side. Once I subtracted 5 on each side, I came down with -x is equal to 6 minus 5 is 1. Divide each side by -1. And so 1 divided by -1 is -1, so x is equal to -1. Over here, subtract 5 on each side, bring down what you have, which is -x is equal to -11. Divide through by -1, and you get x. Divide through by -1, and you get 11. So that's how you do that type of problem. Hopefully you got that one correct. Plug it back in to make sure it works. Next. This one is, so we're going to work on first isolating the absolute value. So the absolute value right now is going to be 3x. 3x is an absolute value. So we are going to isolate it by subtracting 3 on each side. And we get 4 times the absolute value of 3x is equal to 12. Now we're going to divide each side by 4, and we get the absolute value of 3x is equal to 3. Now that we have the absolute value isolated, we're going to create 2 equations. 3x is equal to 3, and 3x is equal to -3. We're going to divide by 3 and divide by 3, and x is equal to 1. We're going to divide by 3 and divide by 3, and x is equal to -1. So these are my two solutions. Okay. So if we want to write this in set notation, well, if we want to do it graphically, here is -1. We put a dot there because that's that solution. Here is 1. We put a dot there because that's that solution. And if we want to write it in set building notation, we're going to say x. I'm going to put a bar here. That means such that. We have to define the variable that we're using. What we're using x's. And my x's are equal to, and anytime we want to put it in a set, we're going to write at least to greatest, so -1 and 1, and close out the set. Set building notation. Thank you.